Schrodinger time-independent equation. A wave equation is given by this equation, which is dou square psi equal to 1 by v square into dou square psi by dou t square. Now, the motion of wave can be understood by the wave definition, which is psi of r comma t. R is the position and t is the time period, which can be expressed as psi of r comma t equal to psi r e power minus I omega t. Now, from the equation 1, we will be solving this part, the double differentiation of the psi. So, t square psi by dt square equal to d by dt of d psi by dt. So, we are applying the double differentiation for the psi. Now, the psi value is psi r e power minus I omega t. We will substitute in the place of psi. And by applying the differentiation, this is the first differentiation and this is the second differentiation which is written outside. The first differentiation, the psi r values are constant, so it comes out, and the differentiation of e power minus I omega t is done separately. Now, e power minus I omega t differentiation is minus I omega into e power minus I omega t. This is because in the differentiation we use the chain rule. So here we have used the chain rule for the e power minus I omega t. As an example, you can consider this d by dx of e power ax is a into e power ax. We have applied the chain rule for the ax, where a is the constant, so that's why it comes out as a into e power ax. In the same way, we have here d by dt of e power minus I omega t. So minus I omega is constant, it comes out like this. So that is the reason why we have written like that. Now, this is the first differentiation which we have completed till now, and now the second differentiation is applied here. In the same way, we will do the same thing. Now, psi r minus I omega is constant, so it comes out, and now we will be applying it to the e power minus I omega t. So the differentiation of this part is minus I omega into e power minus I omega t. It is similar to the first differentiation. We will multiply minus I omega into minus I omega. We will get I square, minus into minus is plus, and omega into omega is omega square. So this is what we got, psi r I square omega square e power minus I omega t. Now I square is minus 1, so we have written minus here, and omega square is here, and psi r e power minus I omega t I have written separately, because we know that psi of r comma t is equal to psi r e power minus I omega t. So this is nothing but psi. So this value is equal to psi. So we will substitute psi in the place of this value. So we will get dou square psi by dou t square equal to minus omega square into psi. So consider this as equation 3. So we have got a solution for this double differentiation of the wave equation or wave function. So this is the thing which we have done till now. Now what we do is, we will substitute this equation in the first equation. By substituting equation 3 in equation 1, we will get this, which is nothing but dou square psi equal to 1 by v square into minus omega square into psi. So in the previously solved equation, we got this equation. This is the previous equation, that is the fourth equation. So in that, we know that omega equal to 2 pi f. 2 pi f. In the place of f, I have written mu. You can write mu as the frequency. So nu equal to c by lambda, as you know, f equal to c lambda. How? Because c equal to f lambda, so f will become c by lambda. Instead of c, we are writing v, and instead of f, we are writing mu. That's it. Now we will be writing omega equal to 2 pi nu. Instead of omega, we are writing 2 pi nu. So it will be substituted here, and mu equal to v by lambda. So we have substituted v by lambda here, and lambda equal to h by mb according to de Broglie's principle. So h by mb. Now this mb goes up, we will get m v square. 2 pi by h is nothing but h cut. So it is reciprocal of h cut, that is 1 by h cut. So we will substitute 1 by h cut here. Now we have squared here, because in that omega square we have substituted omega values like this. So we have to square it. We'll get m square, v square whole square is nothing but v power 4 by h cut square. Now we will cancel this outside v square which we had here. That is cancelled. We'll get m square, v square by h cut. We get this equation. Now as you know, total energy is nothing but potential energy plus kinetic energy. So Total energy is represented with E and potential with V and kinetic energy half mv square. So this is going to the left side, we get E minus V and 1 by 2 mv square. So 2 is multiplied in the left hand side. So we'll get this thing. Now on multiplying m on both sides, in order to get this thing, we are multiplying like this. So we'll get this thing, 2m E minus V. So as we got mv whole square equal to 2m E minus V, we are substituting this 2m E minus V in the mv whole square that we had got before in this equation. So on substituting mv whole square, 2m E minus V, so we will get this equation. And this is the Schrodinger time independent equation.